5. There we go. Just need a new flash. Okay, you guys. March 11th, 19. Okay, so here's what we want to do. We still want to rationalize denominators, but today it's going to be with cube roots, fourth roots. So what we really want to do is we're going to be reducing roots and rationalizing denominators of cube roots and fourth roots and fifth roots. So we'll say of n, we'll go n root. How's that? We'll go of n root or any root. So reducing roots. Okay, we've done that. Reducing roots means to find a perfect number inside and pull it out. Okay, does that make sense? Reducing roots means to find a perfect number inside, perfect number like 4 or 9 or 16. Pull it out, and then that reduces, okay? Now, rationalizing the denominator means making sure we don't have a root in the denominator, okay? Now, Callan said something pretty good early on. She goes, we had those special numbers. So let's put those special numbers down, okay? So first of all, let's put our cube roots, okay? So up here, cube roots, yeah. Now 1 is, but I'm not going to put 1 down. That seems, because we don't need 1. But let's go 8, because the cube root of 8 is 2. Let's go 27, 64, 125. I think it's 216. Is it 216? I think it's 216. 400 and 3. I'm just like 343. Thank you. Oh, you got him. 512. And that's probably enough. And then maybe 216. No. Anyway, that's probably enough. Okay. And then we'll look at probably the perfect fourth roots also. Okay. So what about fourth roots? Okay. Perfect fourths. So fourth roots. Fourth roots. Let's see. We're gonna have a 16, 81, 625. Oh gosh, what's 6 to the 4th power? 1,024? I don't know. Anybody have a calculator real quick? Joe Otto, will you tell me what is
1,296?
1,296. Okay, there we go. Thank you. So we've got the fourth root of 16 is 2. Fourth root of 81 is 3. Fourth root of 625 should be 5. And the fourth root of 1,296 should be 6. Okay, we got them all? So let's take a look. How's that helping you? So example 1. Example 1 is a cube root, right? So let's look up here, okay? So 54. What times what makes 54 that has one of these numbers?
8 and 9.
Well, yeah, but it's got to be one of these numbers.
8's up there.
Oh, yeah, but 8 times...
Wait, 8 times 9.
Yeah, it's 56.
Yeah.
Mm-hmm.
So you could do the square root of 4 times that, and then you get the square root of 216, and the final answer is 6.
Did you do the cube root of 27 times?
It's 27.
Thank you. Oh.
Let's try 27. 27 times what?
2.
Okay, how about the cube root of 27? Cube root of 2. Now, if you're not sure, I mean, honestly, because you guys are guessing, I know it's Monday morning, daylight savings time. If you're clueless, just start with your calculator, okay? And just start dividing these numbers by these. Does that make sense? If you have no clue, just take your calculator and say, well, gosh, I don't know what's going on, but I'll try it. So then, okay, so 27. Hey, it works. So what Callan did is she just started looking at these numbers. She thought, okay, wait a minute. Does 27 go to 54? She tried it in her calculator. Yeah, because we want, if it's a cube root, we want one of these numbers. Does that help? If you have no clue, use your calculator and just start dividing that number by any of these perfect cube roots, okay? So then that's easy from here. It's just going to be 3 times the cube root of 2. And you're done because cube root of 2 is just some ugly number in our calculator, right? Leave it alone. All right? How about example 2? Fourth root. Okay, now, if it's a fourth root, we need one of these numbers, right? 48.
Does 16 go into
Yeah, 16, right? 16 times 3, I think. So we could write as the fourth root of 16, fourth root of 3. Fourth root of 16 is plain old 2 times the fourth root of 3, and we're done. Because the fourth root of 3 is just some ugly number, okay? Now, let's see about 3. Okay, before we go crazy wild on this, I think I could probably reduce 640. Let's just do some easy math. Can you reduce this? Can you reduce this? Because really what I have is like the cube root of 6 over 40, right? I mean, they're both cube roots, right? They're both cube roots, so let me see. I could write it like that over that, but so just if I reduce both by 2, right? If I reduce both by 2, I'd get the cube root of 3/20, right? Okay, now 20. All right, 20. Will 20 break up into anything? I don't think so. So then I'm going to have the cube root of 3 over the cube root of 20, okay? What's 20? What times what makes 20? Yeah, I like that actually. This one's a little bit hard, but I think we can do this. And cube root of 5, cube root of 4, right? Yeah. Okay, so what am I got to get rid of everything on the bottom. How am I going to get rid of the 5? We could. Caleb, what do you think?
You could have just broken 40 down into 8 and
Might have been easier on that one, huh?
minutes.
Yeah. Yeah, it might have been easier. Yeah, let's finish this up. I think you're right. I think Caleb found an easier way to do this one, but do you want me to back up and do an easier way? We already got pen. All right, so let's multiply by cube root of 2, cube root of 25. I think I would have done Caleb's way. Darn, Monday morning. I probably did it the hard way.
Yep.
Want me to scratch this one? I'm going to scratch this one and do it the easier way. I'm going to do it Caleb's way. This is so much harder. Let's go back and do it differently. Caleb, I agree with you. Cube root of 6 over the cube root of 5, cube root of 8. Why is Caleb's way easier? 8 just becomes a 2. Everybody see that? Yeah. Thanks, Caleb. So we'll go the cube root of 6 over the 2 times the cube root of 5. How am I doing? Thanks, Caleb. I agree with you. Okay. And now, let's multiply by what? Yeah, 100, just plain old 25, right? Cube root of 25, cube root of 25. I'm going to run out of room, but that's okay. I don't really need to example 5. So then I'm going to get, you ready? Cube root of 150 over 2 times the cube root of 125, right? Which is going to be the cube root of 150 over 2 times 5, right? Cube root of 150 over 10. Ooh, that was a hard problem, huh? Yeah. Wow. Thanks, Caleb. I would have got the right answer. I would have done it the hard way. Which I do periodically. I do this, okay? How about example 5, huh? Example 5, what are we going to do? Plain old square root. You guys remember this one from our warm-up? Jace? What's that? Yeah. Yeah, I'll let you go ahead and write that down. Yeah. Okay. Yeah, slow me down if I get going too fast. We really did that one the hard way, didn't I? Thanks for seeing that. For Monday morning, daylight savings time. Okay, how about the next example? What do you think? I know, we're not awake yet, are we?
Then you divide it by 2.
Oh, let's do the conjugate. What about the conjugate, huh?
4.
Let's try the conjugate. You guys remember the conjugate?
Now we're doing number 4.
Oh, yeah, you know what? 4. I'm sorry, you are right. Let's go to 4.
You wanted to.
Sorry.
Let's do 4. I'll do 4 over here, okay? What do you think? Oh, 4. Say it. I heard it. I heard
1
it.
and 2.
81 and 2. Good answer, okay? Hi, girls. 4th root of 10 over the 4th root of 81 times the 4th root of 2. Awesome. What's up?
Can we come back in like 10 minutes and grab some people for a picture for the
Sure.
Okay.
Yeah. Okay. So then I still have a 4th root of 10 over, what's that? 3. That's 3. It really is 3. That's 3. How do we know it's 3? It's one of our special numbers, right? 3 times the 4th root of 2. Now what? These are hard. I like this.
Now we need to multiply 3 times the square, the 4th root.
Why am I doing the 4th root of 8 here?
Wait. Number is not.
What number am I trying to make?
You're trying to make
'Cause 16 is a perfect 4th root, isn't it? Right? Trying to make a 16. So let's see what I get. I'm going to get a 4th root of 80 over the 4th root of 16, which is a 4th root of 80 over 2. What's 16 times 5?
Mr.
No,
Dave,
80.
I think you lost the
Yeah, let's do it. Let's do it.
Oh, I forgot the 3's.
Could we
I
say?
see what I did wrong.
There you go. Huh. Interesting. 4th root of, what's 5 times, is 16?
Yeah.
It is, isn't it? 16 times 5? Gosh darn it, you guys.
Let's just cancel out today.
No.
None of us are ready. You're not ready. We're not ready.
I'm ready. Wow, this is even better. This probably gets better all the time.
I was just confused.
Wow, this probably gets better all the time.
Oh, man.
I don't even know what you did there.
You want to show you? Now, I don't know if you guys can see this, but I was looking at 80 and thinking, wait a minute, isn't 80 5 times 16? And I'm like, wait a minute, 16 is a perfect 4th root, right? So I went, okay, 16 times 5, and that becomes 2. And then I can reduce the 2 and the 6 to 1/3. Wow, you guys, these are hard. What a bad day for a Monday, huh? That hard stuff. I'm gonna skip number 5 because we know how to do 5 with the conjugate, right? You already did it, Callan. Callan already did 5. Okay. All right. Oh. Number 6. What do you think?
Conjugate?
Yes. Yes, conjugate. This one's actually pretty easy. I think these were the hard ones. I think this one's pretty easy. Okay, so what do you think? Square root of 5 minus the square root of 3. Square root of 5 minus the square root of 3, right? All right. This times this. 3 square roots of 5 minus this times this. Minus 3 square roots of 3 over. All right. Square root of 25 minus the square root of 15 plus the square root of 15 minus the square root of 9, right? Cancel, cancel, right? Yeah, I'm going to have 3 square roots of 5 minus 3 square roots of 3 over 5 minus 3. I know. Monday morning, daylight savings time, and a hard lesson. Dang. 3 square roots of 5 minus 3 square roots of 3 over 2. Wow. Are your brains hurting yet? Yes. Daisy.
Can we simplify that to 3 halves?
We could, yes. Yes, absolutely. 3 halves here and 3 halves here. Yes, totally right. Absolutely. Okay, now about 7, we can't add them. We can't add them, but maybe, anybody have a calculator? What's this divided by 3? What's this number divided by 3? What's this number divided by 3?
125.
Oh, let's see, minus 5. Cube root of 125 times the cube root of 3. Hey, this one's not going to be too bad, I don't think. Okay, why would I want to do that?
Just simplify it so because the 3 we can add together now.
Yeah, and what's this number?
5.
That's 5. Everybody agree that's 5? So we got 3 times the cube root of 3 minus 5 times another 5 times the cube root of 3. Okay.
Minus 20.
3 times the cube root of 3 minus 25 cube roots of 3. Negative 22? Negative 22 cube roots of 3. Wow, that was painful, huh? That was painful. Okay, I don't think we need to go to the journal today. I think what we need to do is